Today, let's talk about the journey of a packet. Welcome to NetClouders. Please subscribe to the channel if you haven't. What does a journey of a packet mean? So let's take an example here. Let's say a PC here, which is PC1, having an IP address 192.168.1.10/24. That means it's in a network 192.168.1.0/24. That PC called PC1 want to communicate with a PC which is PC2, and PC2 is having an IP address 192.168.2.10/24. And if you have already gone through the subnetting session or the subnetting video that we have put in the channel, you know how subnetting works. We're not going to enter into that particular topic in this video, but what we're going to do is, if a PC having an IP address 192.168.1.0/24 1.10/24 has to communicate with PC2, which is having an IP address 192.168.2.10/24, and if there are switches and routers in between, how does each of these device participate in the communication process so that the PC1 is able to successfully communicate to the PC2? So what we are going to do is, step by step, at every node, we are going to tell you what is actually happening, what makes the packet to move forward, and how it actually happens. So let's get started. As I mentioned, just a recap, what we're going to look at every node in the network is how the PC 192.168.1.10/24 is going to communicate to the destination PC, which is 192.168.2.10. Both are in two different networks, and there are two routers separating it. So there should be some intelligence for the switch to help the PC to communicate to the router. There should be some intelligence in the router which tells that for the PC1 to communicate to PC2, it has to use this particular link. And as human, we will be able to see, and we will be able to see in the picture or in the topology, that we clearly understand this is the path that router has, or the packet has to take for it to reach the destination IP address. But here, what we're going to understand is, how does the router know? How does we teach the router that this is how it has to send the packet? It is this particular interface it has to send the packet to reach that particular destination. So we will go step by step and then understand that. So let's start with the IP packet. As I told, the source, again, we need to go deeper into the IP packet. This session is not intended to do that, but at least you know in the IP packet there are two fields. One is source and destination IP address. So the source IP address is going to be 192.168.1.10/24, and the destination IP is going to be 192.168.2.10/24. So in the IP packet, it actually already provided this information. Now, the next thing what we need to have is the data link packet. Again, we are not going to go deeper on how data link packet is. I think we already have a video which talks about the OSI model, but in the data link packet, depending on if it's an Ethernet packet, there is a packet structure. We are not going to go deeper into that, at least in this particular video. But we do know that there are two fields in the Ethernet packet. One will be the source MAC, and the source MAC address of the PC1, it knows it because it's its own MAC address. It has that information for the PC1, so it puts the MAC address of the PC. Now, what it doesn't know is the destination MAC. It doesn't know right now where it does. The PC doesn't know right now where it has to send the packet to reach the destination 192.168.2.10. And it also doesn't know to which destination MAC address it has to send to. Just to recap of one of the earlier video, this data link packet, or the data link layer, is responsible for sending the packet in a segment. That means in this segment between PC1 and the router 1, its responsibility is to send that frame from PC1 to the router 1. But remember, PC1 has no knowledge that there is a router 1. Now we are going to understand how PC1 is going to get that information, that there exists a router 1 which is having an interface, having an IP address of 192.168.1.1. And then we will also see how PC1 discovers the MAC address. Let's get into it. So here, let's take a deeper look at PC1. As I told you, we are going to get deeper and deeper into each one of the node in the network. First, we will see the PC, then we will see the switch, then we will see the router, and how the next router gets the information and stuff like that. So let's start with this PC1. PC1, as I mentioned, this is the source. 192.168.1.10/24 is the IP address. So two questions you should understand in this scenario. How did this PC get the IP address? There are two methods through which a PC can get an IP address. One is the static IP address assignment. In Windows, there is a particular way of assigning IP address. In Linux, there is a particular way of IP address assignment, not covered in this video as such. But there is another way of another way of getting the IP address, which is dynamically getting that IP address. That means there will be a server sitting somewhere in your network, and that server will be responsible for providing you the IP address. And that server can be your router as well. And we call it as, and how this address assignment happens is what we refer to dynamic address assignment. And the protocol that we actually use is called as DHCP, Dynamic Host Configuration Protocol. We will go deeper into dynamic host configuration protocol in later session, but again, this particular video is not intended for that. So understand that this particular IP address 192.168.1.0/24 has been assigned to this PC in one of the way, either statically assigned or dynamically assigned. And we will have a deeper session on how DHCP work in a separate video or in the training. But right now, understand this is one of the ways IP address has been assigned. Now, once that has been happened, how does PC1 know that there is a router existing and it has to send that packet to the router 1 for it to send the packet out? That is where the default route concept comes into picture. It actually says that where I should send the packet if I don't know where the destination is. So PC, and there is a concept called routing table. This we will go deeper in the session, in the training session only. But right now, understand that there is something called routing table, which is having a font book of all the IP addresses in the internet in a very loosely manner. Let's put it that way. Now, for the devices to have that routing table holding into that memory, it requires a huge amount of resources. And a PC like the PC that you and me have doesn't have the capacity to have all the routing details in the internet, which will be like millions of records. And that is why to the PC we say that you don't worry about your routing part, and PC is not designed to do that. PC for us is for the browsing and other small computing applications. All we tell to the PC is that if you want to send a packet and you don't know where to send the packet, I will tell you an IP address where you will just forward the packet, and the rest will be taken care by that particular guy. And that particular IP address, where we say that everything has to go to a specific IP address, that is called as a default route. In a PC, it's done in a different to configure the routing default routing. It is done in a different way in a Windows PC, and in a Linux PC it is done separately. We will take again in the training only on how to do that. But right now, understand that there is something called default route that gets configured on the PC. Now, last thing is the MAC address. So it now understand, the PC1 understand that it has to send the packet to the router 1 because that is a default gateway that we have configured on the PC1. Now it knows the MAC address of PC1 because it's its own MAC address. And if you remember what we told earlier was, I don't know the destination MAC address, but it does know that the destination IP address, or the IP address where it has to send the packet for it to reach the destination 192.168.2.10 is the router's interface, which is 192.168.1.1. But it doesn't know the MAC address of the router. And as there is a video already there where we talk about the data link layer. Only thing data link layer takes care of is to send the packet from one end to the other end in the same segment. So now what the PC does is it sends a broadcast message. In the data link layer, it is FFFF. Again, it's shown in the video earlier. It says that it asks who is actually having this IP address 192.168.1.1. Whoever has that, get me a MAC address. And it sends a broadcast, and it's only able to send a broadcast because the IP address of the router is in its same subnet. So it sends a broadcast to 192.168 1.0/24, and whoever is having that IP address 1.1 will respond. Now let's see what happens in the switch. We will see what happens in the switch in the next video. Stay tuned for the next video. Thank you.